So chapter 3, describing data using numerical measures. This chapter is going to be concerned with, it's going to start on page 50 of your text. But in chapter 3, we're going to be concerned with describing data, quantitative data, either using measures of location or measures of dispersion. Okay, so we're going to organize it, we're going to assess it, looking at it and describing it either based off of the location or dispersion. Somebody tell me, population mean.
Population mean is the sum of all the values in the population divided by the number of values in the population.
Put that in your own words. It's the average.
Okay.
When we talk about the mean, we are referring to the average. And I'm going to use, if you'll open to page 58 for right now and read to me an example. The example at the bottom of the page, the first row of numbers starting with 11.
11, 4, 10, 4, 9, 3, 8, 10, 3, 14, 1, 10, 3, 5.
And 5. All right, so 11. I'll try to get this. 11, 4, 10, 9, 3, 8, 10, 3, 14, 1, 10, 3, 5. All right. Let's imagine.
You missed a number in there.
11, 4, 10, 4.
4. After the 10 is a
11,
4.
4, 10.
I think a 4 here.
No, the other 10.
Right here. In
Right
front
here?
of the
In
9.
the front.
11, 4, 10,
4, 9. Yeah.
So I need a 11, 10, 4.
Yep.
11, 4, 10.
11, 4, 10.
10, 4, 9.
Yeah.
Yeah.
9. Okay. And let's make sure that we are zoomed. Okay. The population mean. Let's assume that we are concerned, let's make up a hypothetical test, whatever it is. We want to go out and measure, what could we measure using something from 1 to 11? Shoe sizes. Okay, I guess there's a size 1. But we're going to measure shoe sizes based on people who come into a Foot Locker on any given day inside the mall. Our population is only going to be those people coming into Foot Locker during that one day. We're just concerned with this one store's location. Each person who comes in, this becomes their shoe size. This being our population, how would I solve for the population mean?
So it's the average, you add them together and divide by however many numbers are.
Let's do that.
Okay. All right. 11, 4. How many numbers are there? 6.785. Yeah, 95, okay, about 14. I hear you.
All right, so we're going to sum all the variables in the population divided by the number of variables in the population. And when we sum this, what did we have?
95.
95. How many variables do I have included?
14.
What is my population mean?
6.785.
6.875?
Nope, 785.
6.785.
It goes on from there.
Okay, now, to mark the population mean, I'm going to use this symbol here. And if you will refer to page 52, this symbol is our Greek symbol of mu, mu. It is going to denote the population mean. When you see this formula expressed differently, here it is in words. When we see this right here, this is telling me the sum of x, x representing these variables. A capital N meaning number, the number of these variables. So applying this formula, we are going to sum the variables, divide it by the number of variables. Okay. What's the median? We're going to use this same data set just to explain.
What'd you say, what is the what?
The median.
The median.
So that's the
The midpoint.
middle, the midpoint.
The middle. How would I get to the middle? If I were to ask you to find the middle location here, what would be the first step?
Find out what the midpoint of.
So first thing you have to put them all in order.
We would put them in order. Someone put organized low to high. So let's organize these. What do I have first?
1,
1.
3, 4,
So 1, I have 3.
4.
Oh, and then I got
Oh.
3.
There's another one.
I've got 3.
4, 4,
I've got 4.
4. Another 4, yeah.
4.
5,
5.
8,
8.
9,
9.
10, 3 10s, and 11.
Then 14.
11 and 14. So now, where is my midway point?
So would your midway be between 1 and 14?
Or is it between the numbers that you
In this
have?
data set, where is my number, where is my middle ground going to be?
mean, if you wanted to go straight in the middle, it's gonna be
5.
5, yeah, something, or 8. So.
So if I pick this, I've got 1, 2, 3, 4, 5, 6. And then here, 1, 2, 3, 4, 5, 6, 7. It's a little bit easier when you have a.
So you average the two middles would be like a
So
7.
you're going to average, in this case, the two middles.
Mhm.
Which are my two middle numbers?
5 and 8.
So we're going to fall right between those two.
Mm-hmm. So it's gonna be like 6.5 or something like that. Is that right? 6.5, 6.75?
I'm just writing.
Yeah, I know. Asking her if my math was right.
Let's look at page, 57?
Yeah.
Yeah, 6.5.
Now, if you look right under the chart,
Mm-hmm.
and there's an odd number of observation, it's a little easier. Now, how are we going to do it for a even number? We're going to order it. Then what's it tell us to do? We are going to take the mean of the two middle numbers.
Which is 6.5.
So the median is 6.5. So I could say 8 and 5 is 13 divided by 2, 6.5.
Mm-hmm.
Notice that when you have an even number, 6.5 doesn't even appear as one of my variables. So it doesn't have to. You take the median. You take the average of the two middle. Now the last thing, the mode. What is the mode? Very simple.
The one that appears the most frequently.
The one that appears the most frequently. So what number appears the most frequently?
3 and 10.
3 and 2.
So the mode can be more than one number.
If you have it appearing twice on page 58,
58.
the value of the observation that appears most frequently. And in that example, this is where we have our data. Now, the only thing that I want to go back and point, we solve for the population mean. Let's move over and start studying sample observations. How are we going to solve for the sample mean? You're going to solve for the sample mean using the same computation as you did when solving the population mean. However, we are going to have the X bar again, the sum of all x's in a lowercase n. Let the board dry a little bit. And the reason why we separate this under two different formulas, again, as a statistician, as someone observing this data, when you saw this symbol, kind of the U with the little tail on it, move, I'm going to know if I'm looking at this data, it's going to be understood that I'm dealing with a population mean versus the sample mean. So I would know what data am I seeing. Now, let's apply this a little bit. Reference page 61. And we'll see this graph. Now I'm going to, I'm not an artist, but let's just assume this is a perfect symmetrical bar graph. And what I mean by that is down the middle, I have equal sides, so it's evenly divided. What can be said about the mean, median, and mode?
They should all equal him.
They should all equal. So this line is going to be the mean, the median, and mode. Now what happens if I'll show this because questions sometimes arise. We've been taught to think, and I'll say we've been taught to misunderstood, some of us. And what I found from students is that sometimes we assume that the mean and the median are going to be together. However, do not be confused that the mean and median do not have to equal. Remember, one is the average. If we're evenly dispersed around the mean, yes, the median is going to equal at that point. What kind of distribution is this?
Negative.
It's a negative skew. What would cause this to be skewed?
If any of the numbers they don't match, it's gonna adjust the curve.
It's going to adjust the curve. In this case, with a negative skew, now remember, your median is still going to be somewhere, whatever my variables are down here on this horizontal axis, my median is going to be in the middle.
Is it always gonna be in the bell curve in the top of it down? Is that where it's always gonna be?
No,
Your median.
because remember, it's going, wherever the middle is going to
Right.
be.
Okay,
But in this case, my mean is going to be over here. It's going to be influenced by these low variables. It's going to be influenced by the number of low variables. I'm going to have so many low variables, I'm going to draw the mean further out.
Okay.
A good example, think of, play around with these distributions, but if I had a large number of data down in the, we had a classroom of 100 people, okay, and I had, let's reverse this. Okay, if I had, let's not have 100 people, let's have 10 people. All right, so let's say that these 10 people, we're going to give them grades of 100, 100, 99, 98, 98, 98, 100. Then I've got the jokers down here.
that's us.
No, that's you two up at the top. All right, some of jokers down here. Now, let's graph this. So if I was going to put, help me organize this. What's going to go on my vertical axis?
Well, we don't have anything. What?
We'll call this 10 students.
Okay. So the students will go on that side.
So do we want the students here?
Yeah.
And then we'll put grade here.
Yeah.
Okay, so my grades go from, this starts at 1, goes to 10, and this is going to start at 10
I don't know.
and go to 100. So I have, here we have one student at 10. All right, and then at 20, I've got one student. And I'm all the way out here to 97, and I have one student. You can see in this case, and then I got 98 and 99, and 1, 2, 3. So 3 up here, 1 and 2. So I'm going to be graphed looking like that. And that's not a good skew, but you can still see how I'm skewed. My median is going to be between 10 and 100. So what's my median?
The middle is 50.
If I start here at
10.
0,
That's right.
but I'm going to, let's say I start at 10.
Mm-hmm. So we 60.
So my median will come in halfway,
Oh.
45.
Yeah.
But my average grade
Mm-hmm.
is going to be what?
98.
So is this where we add them all together and divide them? I mean,
Yeah.
divide by 10?
Yeah.
So let's just say we're calling this our sample.
Okay.
So what does my
82.
82? So I reversed it from the negative skew. I'm leaning toward more positive skewness here. And again, the mean is influenced by all of these higher grades. Yes, the median gets dragged down because of the two jokers.
Mm-hmm.
But again, the number of strong positive grades is going to cause a rightward shift in our curve. You don't realize it, but that was a quick economics lesson about shifting of the curve. I told you I found a way to bring economics to this class. Okay, so let's look at another example. What is the weighted mean?
A way to compute the mean when there is several observations.
A way to compute the mean when there are several observations
Of the same value.
of the same value. Expressed differently, when there's a repeat of one variable you want to, or one value, you want to take into consideration that repeat. And rather than use the word repeat, let's just use the word await. Await, like weighted average.
Mm-hmm.
Okay, so you want to weight it by the number of occurrences that you see or that you observe. Give me a good example of a weighted average. Probably the one that you know best.
Hourly employees.
Hourly employees, but in this classroom, what's one that you should know best?
Our grades.
Your grades. Specifically, your grade point average. Now, how is your grade point average weighted?
Add them all together and divide out how many classes that you've had.
More than classes, how many points you get for an A?
4 points, I think.
So for an A, we'll weight it 4 points, a B will weight it 3, a C is weighted 2, a D is weighted 1, and 0. And you're going to take the number of credit hours and whatever grade you have on those hours, you are going to multiply it by this weight. And then we come all the way back over here and we sum the observations and divide it by the number of observations. It's going to be solved the same way as you solve for the population mean and the sample mean. The only thing that we are doing differently is multiplying here. We good?
Yep.
Okay. Now that's going to conclude the location part. Well, why do we want to even look at dispersion?
Dispersion is broader.
Okay, I think we're going down the right road.
The definition is the spread of data or the spread in data.
The spread in data.
Okay,
How is the data spread?
all right.
On page 68, a measure of location, such as mean, median, or mode, only describes the center of data. If you notice, we were paying attention to and studying the center of it. Now what we want to do is measure the dispersion. Specifically, we'll talk about how far are we spread.
Okay.
A small value of dispersion, if we see that we are going to be, our dispersion is low, it's all of our data should be clustered in some area. So if we see all of our observed data is clustered, we say we have a small amount of dispersion. If we have a wide spread, we'll say we have a lot of dispersion. All right, so I'm going to pick back up again on page 69. And at the bottom, a second reason for studying the dispersion in a set of data is to compare the spread in two or more distributions. If I wanted to take two, right now we've only assumed one observation. If I wanted to take two observations and put it on the graph, again, I could compare those two by how they are spread. So let's look at a good example. All right, so let's say that refer to chart 3.6. All right, so let's go to 3.6. All right, so let's look at this example. 48, 49, 50. Is it 51 and 52?
Yes.
Okay, now what are we studying here? Hourly production of computer monitors at a Baton Rouge plant. And I have 5, let's do it down here. And how far am I within 3? What do I spread between?
Maybe
49 and 51.
51. And then 50.
And then 50.
Yeah.
So let's spread this first one a little bit.
Spread all the way 50.
Yeah, so we're going to be bigger. We spread the whole way.
Mm-hmm.
From the minimum to the maximum point, what do we call this? The range.
The range. Okay.
So let's just look when I talk about data being clustered. Is there greater or less dispersion between here and here? There is greater dispersion up here.
Mm-hmm.
Here, my data is clustered around that 49, 50, and 51.
Mm-hmm.
Even here, I have less. I'm all clustered around 50. So again, when I see a small amount of dispersion, I expect the data to be clustered, meaning just in more close proximity. When it is spread, we expect to have greater. Now I want to next move into a conversation involving variance. And what's the variance?
The mean of the squared deviation from the mean. The arithmetic mean of the squared deviation from the mean.
Squared deviations from the mean. Okay, so the maximum and minimum. The variance does. So it says here, a defect of the range is that it is based on only two values. So remember, the range, we're only concerned with smallest
And largest.
and largest.
Okay.
Okay, so we'll call this the minimum and the maximum. It does not take into consideration all of the other variables in the middle.
Right.
And now the variance will. The variance is the squared deviations from the mean. And I'm going to go ahead and move over into all right, and read that definition to me again.
The arithmetic mean of the squared deviation from the mean.
Okay, so you're going to take the value of the variance, you're going to take the square root of it, and that's going to give you the standard deviation. And I'll explain this real quick. The standard deviation let's say that I have a let's see that my range is going to be 0 to 10. And let's just say I have, we'll do 10 observed values again. So we'll do 1, 2, 3, 3, 5, 6, 7, 7, 9, 10. What's my average here?
And there's 10 there. 5.3.
So 5.3. So let's just say this is 5. And I'm going to call this 5.3 right there, just a little bit off to the side of that. But I'm also going to have values of 1, 2, 3, 6, 7, and 9. So when we talk about variance and standard deviation, here is my mean. But I want to study how many, I want to quantify how far or how much disbursement should I expect off of this mean. Remember, the range is only going to be concerned with 0 to 10. But here I want to study how far do I have data surrounding the mean.
Oh, away from, so you're trying to find out how much data is, how far away that data is from the mean. Is that what you're trying to say?
I want to see how far that value is from the mean.
Okay.
Now let's just say that, well, let's not just say, let's solve for it. And let's use this example from the book. What do we have, an airport there?
Yep.
All right, so in the airport, California airport. So we've got a California airport. And where am I? Orange
County and Ontario.
Ontario?
Yes.
Orange County and Ontario, and 20, 40, 50, 60, 80. 20, 40, 50, 60, 80?
Yes.
And what's Ontario?
20, 45, 50, 55, 80.
What are we quantifying up here?
Passengers, probably.
Excuse me? What do these numbers represent?
Cappuccinos sold in Starbucks.
All right, so cappuccinos sold at Starbucks. All right, what are we asked to solve for?
It wants the mean, median, range, and the variance.
In the variance. So the mean, median, range, and the variance.
And then the differences in those measures.
All right, so what's the mean here?
$50.
So for the sample, let's call it here. The 50 here.
50 on this side tonight.
50 on both sides.
The middle, yeah.
Yes.
What's the median?
$50. And 50.
50 and 50. And what's the range? Minimum to maximum.
20 to 80.
So my range would be 60.
Mm-hmm.
And my range over here
The same, 20 to 80, 60.
is the 60. All right, now the variance. What variance are we going to have in Orange County? How do I want to solve for the variance in Orange County. If we look, we are going to take this first observation, and I'll call this variant. I'll do it right here. So 20 was my observation, and what's my mean? Equals what? 50 minus 30. Now here, 40 minus 50 minus 10. 50 minus 50 is 0. 60 minus 50 is 10. 80 minus 50 is 30. And here I have the same mean. So what am I going to do with this data now? I then take this number and do what? When you ask, this is how the formula works out. So this is why we're doing it this way. So let's get our calculators out. And let's take 30. And if I take the square root of 30, what do I get? 900. If I take the square root of minus 10 multiplied by minus 10, what do I get?
Is that 900 going to be a negative?
When I take a negative and then multiply by negative, what do I get?
Yeah.
I get the
All
positive.
right.
So here, 100, square root of 0 is 0. And what's the square root of 10 again?
100.
100 and 900. You ask, why do we do it this way? We do it to take the square root to turn this variable from a negative to a positive.
Okay.
Now I sum this. And I get 2,000. And then I divide that 2,000 by 5. It's the number of observations. And my variance is going to equal 400. So let's just stop right here. Now, because we squared, remember, we squared in order to change that negative to a positive. What do we have to do now, you think? We take the square root of 400, and what do I get? This is going to mark my standard deviation. So I want you to jump all the way to page 75 in your book. When I take the square root of 400, what do I get?
It's 20.
Okay, so let's interpret this. In Orange County, there are an average of 50 cappuccinos sold during this day. So Orange County is going to sell an average of 50. That could be, though, if I look at any single observation. So across the board, 50 or so. But if I was to pull out any single observation, I could expect it to be plus or minus 20. So if I took a look at, how many flights did I have? 5.
5, yeah.
Okay, so across these 5 flights, an average of 50 cappuccinos were sold. But any individual flight, let's just say I pulled out the first one, it could have been either 70 or 30. That particular flight could have sold 70 cups or 30. Remember, with variance and standard deviation, I'm looking at what is the dispersion around the mean. The mean is going to be the average across all 5 flights. But any individual observed value, it could be plus or minus. In my world of investing, look at this portfolio. If I were to present this to, I'm going to assume here, each of you have, let's just assume we have a 401k plan or a 403b, some type of retirement plan. And you were presented with this investment. I see right here where the average return, let's see here. My normal disclaimer here is, as an investment advisor, this is not a solicitation to invest in this product. This isn't solicited as investment advice, not intended as a buy or sell recommendation. Please consult with your own tax or financial professional. All right, so I see where standardized, non-standardized returns. Year to date, this investment has generated 6.03%, or 5 years, 10.99%. Now, does that mean that that individual investing in this product received 10.99% every year? No, that's an average across those 5 years. I see, so let's go up and look at the standard deviation. And I see a standard deviation. Where are we? Where are we? Right here, 11.21. That means that over the 5 years, this individual could have gotten 10.99% plus or minus 11.21. So at any given year, you could have had as much as a 22, I'm rounding, a 22% return, or you could have had as much as a negative 0 to 1%. Across the 5 years average, I earned 11%. But if I went back and looked at each individual year, I could have been as much as 11, or whatever that standard deviation was. So back to our cappuccino. Across 5 flights, we sold 50 cups of cappuccino in Orange County, Florida. But on any individual flight, I could have sold as many as 70 or as few as 30. And that is standard deviation. It is a measure, when you think about it, it's a measure of volatility. And that investment right there, that was a measure of volatility. It was used in my world as a risk factor. In presenting risk to someone, how much volatility should you expect by making this investment? In this case, how much volatility would we expect for cups of cappuccino? Okay. Any questions?